So when you use an electric motor, one of the things you have to deal with is called the back EMF. So again, electric generators turn mechanical energy into electrical energy, into current. And electric motors take electrical energy, current, and turn it into mechanical energy. So they're two sides of the same coin. Now, when you're doing work with a motor will generate an EMF because you're putting current through a wire. That current generates a magnetic field, and as that motor spins, that magnetic field changes. So it generates an EMF. It generates an EMF that's against the driving EMF, the external EMF that's driving the circuit. So it's called a back EMF. Again, Lenz's law states that the current resists the change in flux. So when you push current through a motor for the first time, you're spinning current through that coil of wire, which generates a magnetic field that's changing the magnetic flux in that coil of wire. So the motor produces a back EMF to try to prevent that from happening. It fails, but it tries. So that generates a back EMF. So when you plug in a motor or turn it on for the first time, especially a very powerful motor, you might notice that it draws a lot of current. For example, in some old houses, where the refrigerator first turns on, the compressor first turns on, the lights might dim a little bit in the kitchen, or whatever else is on that circuit. So once the motor begins to run and has current flowing through it, and the magnetic field is established in those coils, it's not changing anymore. Therefore, there's no significant back EMF at that point. So the current drops. The back EMF is also what creates a spark. So, for instance, if you've ever had a machine that's running, like your hair dryer is running, and you pull the plug while the hair dryer is running, or you pull the plug while your curling iron is going, or you pull the plug while your fan is blowing, you might notice that you'll see a spark coming out of the wall outlet that you don't get when the device is off. So you turn your fan off, you pull the plug, nothing happens. If your fan is running and you pull the plug, on occasion, you'll see a spark. That spark is also back EMF. Again, if you think about it, the motor in the fan is running, turning electrical energy into mechanical energy, right, pushing air. When you pull the plug, you go from having a current in those coils of wire to zero current in those coils of wire. And therefore, since you're going from a positive current to zero current, the magnetic field goes from a very strong magnetic field in the solenoid in that coil of wire to no magnetic field. That's a significant change in the magnetic flux. So an EMF develops that tries to prevent that current from stopping, which is why you can get a pretty significant arc of electricity even after you've unplugged it. The potential is high enough to jump the gap, like if you've ever rubbed your feet on a carpet, touched a door handle, and you get a static electricity spark. This is very similar to that. It's a high potential spark across the gap in air you can see as light. Basically, it's the motor trying to prevent itself from being turned off. It's the magnetic flux the current from Lenz's law, trying to prevent the change in magnetic flux. So make sure your devices are off when you unplug them, otherwise you can create a spark and, of course, create a fire hazard. So this is the very simple concept of a back EMF in a motor.